Welcome to Unit 6, Day 5. Today we are going to use dimensional analysis to convert between grams and moles. We are able to go directly from mass in grams to the number of particles. And remember, we talked about particles last time. That can be any number of things from atoms, formula units, or molecules. We use the word MAP-FU to help us remember. Those are all different types of particles, and we use Avogadro's number and molar mass in order to do this. This is actually really simple. So we're going to switch over to the document camera and I'm going to show you with some guided practice. So don't forget, Avogadro's number is 6.02 times 10 to the 23rd, and remember, you always start by boxing and circling. So let's switch over to the document camera, get your calculator ready, and have a periodic table. So we're always going to start by boxing and circling. So I'm going to box my given. In this case, it is the 29.021 grams of helium. And I'm going to circle how many atoms. Okay, so box your givens and circle your unknowns. And we're going to start by always start the same way with these. Put what you are given in the top box. So I'm going to put that 29.021 grams of helium. I'm going to disco down, because we always disco down our units, grams of helium. Alright, so now I'm going to use my periodic table. So here is helium, its mass, okay, and 1 mole is 1.008. Okay, so I'm going to put that in the grams box. Alright, so now these are super easy to solve. We're looking for the number of atoms. And 1 mole is not only equal to the molar mass, but it's also equivalent to the number of particles. So if I put the molar mass down here, I'm solving for atoms. I know that 1 mole is equal to not just the molar mass, but it also contains 6.02 times 10 to the 23rd atoms. So, just a little bit of dimensional analysis. Once again, make sure you are aware of how to enter exponents into your calculator. If you have a slightly different calculator than the TI, there is still probably a way to do that, and get in touch with your teacher if you need help figuring out how to enter your exponents. So just like before, we're going to solve these the same way. We solve them by multiplying everything on top. So you can do it all in one step as long as you use parentheses. So I'm going to use my parenthesis. I'm going to enter in 29.021 times 6.02. And now this, instead of the times 10, remember you can use your EE key, or on some calculators it might be second EE. And that represents the times 10. So I just need to put in the exponent, close your parenthesis, and then you divide by everything on the bottom multiplied. But because we only have one thing there, we can just say divided by 1.008. Enter. Okay. So my answer is 1.73 times 10 to the 25th power. For your rounding, if you take it out to maybe 3 places, I would say you're pretty safe. So if you wanted to say 1.733, you could do that as well. Don't find it necessary. It's not necessary to write all those digits. So my answer is 1.73 times 10 to the 25th atoms. Remember, you have to include your unit of HE. So my full completed answer needs to include the units. Okay, next problem. Start by boxing and circling. This one says how many molecules are found in 36.07 or 0.87 grams CO2. We're looking for how many molecules, okay? How many molecules? So here we go again. We are going to start with what we are given, 36.087 grams CO2. We're going to just go down my unit, which is grams CO2. And we were so nice. We gave you the molar mass. We did not make you calculate it. So I'm going to take that number, and I'm going to write that out, 44.009. And what's going to go on top? Molecules. How many molecules are in 1 mole of anything? It's always going to be that Avogadro's number. That's 6.02 times 10 to the 23rd molecules. All right. So I'm going to plug it in just like I did before. Open a parenthesis, and then you're going to say 36.07 0.87 times 6.02, that E key is the times 10, so you don't have to worry about that, just the 23, close your parenthesis, and then divide by what's on the bottom. So I'm going to divide by 44.009. All right, so my answer is 4.94. I'm going to round that up because that's 6. 4.94 times 10 to the 23rd power. So 4.94 times 10 to the 23rd. And that my full total answer needs to include the word molecules, CO2. Molecules of CO2. And then I'm going to box it. Okay. Next one, how many particles are contained in 253.36 grams of, we've got some zinc sulfide. Once again, we gave you the molar mass. Box and circle, box and circle. We're looking for particles given this amount, and then we also gave you the molar mass instead of making you calculate it. So I'm going to write what I'm given. 253.36 grams ZNS. Disco down your units. So I'm going to disco down grams ZNS. We have the molar mass. It is 97.446. And then what goes on top? Once again, particles. It's all part of that. Molecules, atoms, particles, formula units. It's all the same. It's all Avogadro's number, 6.02 times 10 to the 23rd particles. See, these are all very similar to solve. Just have to know how to put them together. We're going to do the same exact thing. I'm going to open a parenthesis, and I'm going to just take the numbers in the top and multiply them. Times 6.02, close your parenthesis, divided by 97.446. Hit enter. Okay, so my answer is 1.57 times 10 to the 24th power. And that is particles of ZNS. To get full credit on your answer, you need to include the entire unit, which is particles ZNS. All right. So, guess what? We can also go from mass to moles with the exact same process. If you write out all your units and just go down, you will always know exactly what to do. That's the wonderful thing about these problems. They can all be solved the exact same way. All right, so if we box and circle, we've got 1.98 times 10 to the 23rd atoms of titanium. That's what I've been given. And I'm looking for mass. So I'm just starting in a different direction. But if you always write your units, they tell you what to do. So I'm going to write 1.98 times 10 to the 23rd atoms Ti. I'm going to just go down my unit. Atoms Ti. And I'm looking for the mass. So the mass, I'm going to use my periodic table. I'm going to look for titanium. There it is. It's got a mass of 47.867. So the mass is on top, 47.867 grams. Now, just like before, I'm going to show you this picture again. 1 mole is equal to the molar mass, which is equal to the number of particles. And so atoms are particles. So this has got to be 6.02 times 10 to the 23rd. All right, so now we're just going to solve it just like we've been doing before. We're going to multiply the numbers on top and divide by the numbers on the bottom. So I'm going to multiply using a parenthesis, because if you don't use the parenthesis, you will run into problems with your order of operations. So if I just wanted to put everything in the calculator at the same time, it would not give me the correct answer. So please make sure you use parentheses. 1.98. Hit that EE key or your equivalent on your calculator. 23rd times 47.867. I'm going to close my parenthesis, then divide by what's on the bottom. The 6.02 times 10 to the 23rd. And I'm going to hit enter. All right, so my answer is 15.74 grams of titanium. Box your answer. And let's do another one. Okay, what is the mass? That is what I'm looking for, my unknown. And here is my given. I'm going to box that. 8.500 times 10 to the 23rd atoms of xenon. Always start these problems the same way. Put what you are given in the box. 8.500 times 10 to the 23rd atoms Xe. Yes, you have to write everything out. Looks like this pen's dying. Just go down so I know I have to bring down my unit. That tells me what to put there. Atoms, Xe. Because when I hear the word atoms, I want to be thinking, oh, atoms. Okay, that's included with Avogadro's number, 6.02 times 10 to the 23rd. That's what's going to go on the bottom. So when you write the unit, you're doing yourself a favor because it tells you what to do next. And then what goes on the top? That's the mass. So I use my periodic table. I look for xenon, and then I just copy it. So it says 131.294. And then I'm going to solve just like I did before. You're going to multiply the numbers on top in parentheses. 8.5 to the 23rd times 131.294. I'm going to close my parenthesis and then divide by my number on the bottom. That's 6.02 times 10 to the 23rd. And hit enter. So that is going to be 185.38 grams of xenon. And let's practice one more example. What is the mass of 1.187 times 10 to the 24th molecules of Cl2? Okay, I'm looking for mass, that's my unknown, with a given of that 1.187 times 10 to the 24th. So I'm going to put that in my top left box. And write out my unit. And I know this is long to write out, but it really does help. Because if I write it out, then I know I need to just go down. And that molecule, the word molecule, will help me remember, hey, molecules. I have to associate that with that 6.02 times 10 to the 23rd. So whether it says atoms, molecules, formula units, particles, that's what we're wanting you to think about. 6.02 times 10 to the 23rd. And I'm solving for, the number on top is the mass of Cl2. So grams Cl2. For that, I want to use my periodic table to get the molar mass. Okay, so importantly, I've got Cl2 here. That means I need to take this number for the Cl, and there's 2 of them. So I need to multiply this 35.453 by 2 in order to get the correct answer. So the molar mass here, be careful and make sure you get the correct molar mass. So I'm going to say, to get the molar mass, I'm going to say 35.453 times 2, because it is Cl2, there's 2 of them, and that will give me a molar mass of 70.906. And now I'm all good to go. I'm going to solve. So I'm going to take the number on top, my 1.187 times 10 to the 24th, times the molar mass, which I just calculated, that's 70 times 70.906, close my parenthesis, and divide it by the number on the bottom, which is my 6.02 times 10 to the 23rd. Okay, so my mass here is 139.81 grams of Cl2. And that's it. Today's lesson was a little bit shorter, so on to that homework. Great job.